Covalent bond of semiconductor. So in our semiconductor, there are several types of material, suppose silicon, germanium, arsenic, gallium, and all the semiconductor are using covalent bond to join with each other. But there are two types of bond in chemical engineering or in chemical science. First one is covalent bond, second one is ionic bond. In ionic bond, the two atoms are receiving and also donating the electrons between themselves and making the bonds. But in case of covalent bond, they are not donating, or they are not receiving the electron from each other. They only share their electron or outer shell electron so that they can easily make the bond. So this covalent bond is following the semiconductor. So there are some semiconductor which can easily making a bond to each other by using this covalent bond. For making the covalent bond, the semiconductor which have 4 valence electron can easily perform this covalent bond. Suppose we have one semiconductor, the very popular semiconductor, which is silicon, and the atomic number of silicon is 4. If we want to write the electronic configuration of semiconductor silicon, then it will be 2, 8 and 4. So if we add this three number, then we get the 14, and this 14 is atomic number as well as the electron number of a semiconductor atom. So here there is atomic structure of semiconductor. The first shell contains only 2 electron that I denote by a point. Then the second shell contains 8 electron, and each electron are making pairs in that shell or energy shell. And the third energy shell or the outermost orbits contain only 4 electron. So we can denote this 4 electron by using 4 points. So here there is a thinking of valence electron because it is the tetravalent, as it has 4 electron the outermost shell of the atom, so it is called the tetravalent atom. So silicon is our tetravalent atom, and this tetravalent atom contains 4 electrons at its outermost shell. As well as the germanium is one kind of semiconductor, it is also containing the 4 electrons at the outermost shell of its atom. So when we get the 4 electron as a outer shell electron or as a valence electron, this material can easily making the covalent bond, and this covalent bond is made by sharing the electrons between the two atoms. Suppose there is another structure which denotes how the silicon can attach to the another silicon by using this covalent bond. So here are the four another new silicon semiconductor. In the center, this is our central semiconductor, and this red shaped orbit indicates the outermost shell of that semiconductor. Now there are 4 another semiconductor or silicon atoms which can touch to each other by using this covalent bond. So now I want to share with you how this covalent bond is making. Okay, first of all, this silicon is central atom and it has 4 outer shell valence electrons. So this 4 is our valence electron, and this 4 valence electron can easily share the another 4 electrons with it and making the octet at the outer shell of the silicon, because we know all of the atoms are all of the atoms are trying to make the octet so that it can get the stability. So this silicon has 4 outer shell electron. One is this, another is this, another is this, and fourth one is this. And also the green shape or green colored orbit, it also indicates the another silicon atoms. So this silicon atom also contains the 4 valence electron. Suppose this 4 valence electron is 1, 2, 3, and this is 4. This silicon atom also contains the 4 electron at outer shell. Suppose 1, 2, 3, and this is 4. This silicon remains same, that is 1, 2, 3, and this is our 4. And last silicon semiconductor, it contains another 1, 2, 3, and this is 4. So now this 4 silicon semiconductor shares their outer shell 1 electron to the central silicon atom, and you can see the central silicon atom can easily contains the 8 electron, where the 4 electrons are from the central atom and the another 4 electrons from the outer 4 silicon atoms. So here this central silicon atom contains 8 electron at the outer shell of its orbit. So this silicon can contain the octet at its outer shell, and this silicon atom remains stable. So here this is the way how the silicon can combine to each other and also sharing their electron between themselves. But here if you see this silicon is also containing another silicon atom. Suppose this is the way one silicon atom, where this silicon atom share this electron to there, and it also contains another silicon atom, it also contains another silicon atom, where other silicon atom can easily share their outermost 1 electron to this silicon atom. That's why this silicon can also contain the 8 outer or 8 electrons at its outer orbit or the outer shell. That's why this is the way how the electrons between the two silicon semiconductor can easily share to each other and making the covalent bond. Here there is no electron donation or no electron receiving, only the electron can be shared, and this electron can easily make the covalent bond. So here there is a silicon semiconductor structure, and if you see there are 4 bonds in a silicon semiconductor, and this silicon can easily making the covalent bond with another 4 silicon semiconductor atom, and there it can share it can share the 2 electrons with another silicon atom. Suppose this is our another silicon atom, and also this silicon can share the another electron with another silicon atom. In that way, it is making a huge structure, because this silicon is also contain another silicon atom, and also it share its electron to another silicon atom. So now if I draw this silicon atom, which can easily making the bonds of covalent bond to each other, then our structure is like this. So you can try to draw this structure in your home, and also you have contain how the electron can easily share, you can indicate how the electron can share by each of the silicon atoms. Now, if you look at the germanium material or germanium atom, this is the central atom of germanium, and this germanium has also contained the 4 outer shell electrons. Suppose these are the 4 outer shell electron of germanium, and these 4 outer shell electron can easily making the covalent bond of another silicon material or another germanium material. Suppose those are our another germanium atoms, and this germanium atom have only 4 outer shell electron, and these 4 outer shell electron can easily making a covalent bond to another germanium atom. So if I want to show this in a very simple structure, then this is the way. Here the germanium is our central atom, and it contains the 4 hand, we say it as a hand, and each of the hand contain another germanium atom, and each of the germanium atom has also 4 hands, and each of the hands can easily catch the another germanium atom and also share their outer shell electron to make the covalent bond. So to produce any covalent bond, we just share only 2 electrons. So if any atom want to making any covalent bond to another atom, then it share only 2 electrons to its one hand. So these two are 2 electrons in one bond, and these 2 electrons are also making the covalent bond between the two same type of semiconductor or different type of semiconductor. We can replace this germanium by using silicon, because silicon have also four hands. So this is the way how the covalent bond is making by using the sharing technique of electron. The covalent bond is building in a semiconductor. So each of the semiconductor contains the four valence electron, or maybe there is four. Okay, this is actually four. So four electrons is called valence electron, and this valence electron do not donate the atom do not donate these four electrons, or do not receive any electrons from outer shell or any atom. So this four electron is working as a sharing of another atom and also making the covalent bond. And another thing that I want to share, the ionic bond is very strong. But in covalent bond, if we want to talk about covalent bond, this is not so strong as ionic bond. So we can easily break down these types of semiconductor, but we cannot break down the ionic material. Suppose some ionic materials or ionic bond type materials, because the ionic bond is too much hard, but the covalent bond is lower. So in that cases, we know about the covalent bond of semiconductor. Now I want to share another thing with you. The people who are watching our videos, please like, subscribe and press the bell icon of our YouTube channel, so that you will get our notification of any new videos. And also the people who are using the social media like Facebook, Instagram or Twitter, please upload your status as hashtag crush school on your public post, so that I can easily communicate with you. And also the people who are watching this video, maybe you are an engineer or engineering student, then you can visit our website, which is thecrashschool.com. Here you will find the various items about the engineering sector and also technical subject.